Okay, so on the agenda tonight, Arun and other folks from Intel are gonna give us some more information about their proposal to support CNF use cases in Antrea. And if we have some time remaining after that, we'll have like an open discussion in case folks want to bring up some issues. All right, Arun, Saidilu, you guys can take it away.
Yeah, thank you, Antonio. Arun, you can start the slides.
Yeah, sure. Let me share here. Let me know when you guys can share, see the screen.
Yeah, it's
Yeah,
all
it
good.
came up, Arun, yeah.
Sure. Hi, good evening, everybody. So this is the follow-up discussion to have a little more deep dive on the CNF proposal we made a few weeks back. Before we go with this, I would like to request Saidilu to recap a little bit on the CNF use cases and stuff which we discussed last time. So Saidilu, would you like to give a few words?
Yes, Arun. Yeah, as we discussed last time, CNF and CNF use cases to support service functional chain. And also byproduct, we are going to provide the details on how we are going to support the multiple interfaces, including the SRIOV or any subnet, any virtual network interface. And also going forward, how we are going to support the service functional chain to support the multiple service functional chains, which is one of the common use case on the SD-WAN and other areas. And also we are going to expand the solution. We are going to show the solution how we are going to expand further on the load balancing on when multiple service, multiple function instances are supported. So how we can load balancing within that one. That is what we are going to present today. And we start with the use case. What is the current use case? How we are looking it, and why multiple interfaces are required to support the service functional chain. From there, we are going to present virtual virtual networks, how we can create that and how we can maintain within Antrea scope. And also, we are going to present how we going forward. We are going to support multiple interfaces. Yeah, I think we can go to next slide here.
Sure. Yeah. Thank you. I think Stephen Wong has some question, or we couldn't hear you.
Yeah, just in case we've got newbies here who don't understand the terminology, can we define CNF, VNF, and SFC in this slide so that people who tune into the broadcast can get a definition and know whether they're interested or not?
Yeah, sure, Stephen. CNF is a cloud native function. Something VNF is like virtual native function. Example, if you see firewall, we can have the physical appliance, or we can have the VNF, and CNF is a cloud native form of the same network function. And SFC is service functional chain, how we can chain together all these CNFs and VNFs based on the certain required criteria. And we have details on how showing up CNF, VNF, and service functional chain in the next slides.
Great. Yeah. Thank you, Saidilu. Thanks for the quick summary on what we tried to cover today. Hope it was clear for the community people. Let's go with this right now. So yes, Saidilu mentioned the actual problem statement here is the CNF deployment and network function chaining support on Antrea CNI, right? So to enable Antrea to support the CNF deployment and also a service function chain of CNF functionalities, not limited to though, but we say currently it's specific to CNF for Antrea while we use Antrea as a CNI for Kubernetes. And obviously, one of the main criteria for that is multiple interface support on Antrea. As all of us know, it supports only a default network interface right now. All the communication goes through the default interface, which is created based on the Kubernetes CIDR, right? So to support the chaining, we need more than one interface. So we need to add support for that also in Antrea. Actual requirement to achieve this is to support dynamic virtual network configuration. We'll see in a while like what it is exactly about, and a provider network, and multiple interface support per pod. That's what we saw as part of the problem statement too, and functional chaining. Right, so this would achieve the typical CNF use cases. So to achieve a typical CNF use case using Antrea, so we need to support these requirements. To make things a little more clear, so we took an example specific to SD-WAN security network function chaining. So this we can see that there is a core network here. You can call it as a provider network. Okay, so it is kind of your building WAN or the ISP or whatever, right? So you take the core network in this case, and then you have a Kubernetes cluster. So where you have a bunch of microservices running, and so you have the network definitions like a provider network that is left, right, and then you have virtual networks defined. So these blocks are actually your CNFs. So the SLB is the service load balance. This is next gen firewall and SD-WAN CNF, right? So we are not deep diving into what these guys do. Basically, all I want to communicate here is these are the CNFs which we are looking to add support for, right? So to see the actual traffic flows, what we are supposed to enable configuring through Antrea is like one of the thing is like from one of the microservice, you need to go through the CNF to chain your traffic communication from your microservice to the external network. Okay, this is one use case. I don't know, it's some water's hung here. Yeah, you see that? So the next use case is actually from the core network to one of the microservice pod. And another use case is possibly like, so we're not even getting into any of these services. It's communication from the core network to the external world, right? All of these communications has to go through a chaining. Mainly we want to load balance it, and you want to traffic shape it, or kind of firewall protection here, right? And then the SD-WAN use case is achieved at this exit, and it goes to your right provider network. Right, these are the use cases. These are the traffic flow patterns which we aim to support when we claim Antrea can support the CNF use cases.
Arun, to add here why virtual network support is required and multiple interfaces, you can.
Oh, sure. Yeah. So basically yeah, thanks, Sailo. So the virtual network support is required here to enable chaining between the CNFs. Right. So when a packet reaches your SLB, there should be a way for it to communicate or go through your further chains to the external network. Right. This flow is defined by the CRD. So we have virtual networks defined between CNFs to have your communication moving forward. Yeah. So any questions?
And also to add to Arun here, we are not suggesting any changes to service functions like SLB next gen firewall. There will not be any changes within the applications or microservices.
Exactly. Yeah. So these will be seamless. The configuration, what we try to achieve with the virtual network and things will be seamless to the CNF functionality itself.
Hello, I have a question. So
Sure.
the virtual functionalities are deployed as pods, or they are deployed as virtual machine appliances?
These are not parts, a pretty good question. So these are the virtual network, which we kind of picturized it here. This is going to be logical. So basically you're going to create another interface here, right? So the interface subnet would be defined in terms of the virtual network CRD.
And
Okay,
SLB,
I mean SLB in GFW, are these pods or
those are parts. Yeah, those are
okay,
parts.
Those
understood.
are parts. Yeah, exactly. Those are parts. This is the logical communication path for you, where we say it's as simple as that you have a subnet defined here. So the gateway for this interface would be the gateway, the right net, the left network of your NFG, NG.
Okay, understood. Thanks.
Sure. Any other questions here? Okay, let's move on. This is the sample virtual network CRD. So as we saw here, these are the virtual networks which we plan to define, right? If there is a CNF use case, not limited to one or two, just we showed an example here. This basically tells us the subnet, right? So what subnet I'm belonging to, what is my gateway IP address in this case, right? So we define virtual network 1, virtual network 2, and there can be, in this flow, you can even use SRIOV interface itself. If the pod supports, or the CNF, the platform where the CNF is running, it supports the SRIOV, we have a CRD defined for SRIOV use case as well, right? It's from the Antrea point of view, it's another network interface in this case for us. Right, so the key point here is the subnet information for the virtual network is maintained in the global IPAM, right? So we would expect the Antrea controller to provide the IPAM for the specific subnet in this case, right? So if a pod is defined, like when we go through the network chaining CRD, it may be a little more clearer. So when a pod or a CNF is trying to join network chain, right? So controller should realize that, and he should be able to assign an IP address using the global IPAM. Right, so we're going to use a global IPAM to allocate IP address. So current traditional thing with Antrea is like we have a local IPAM, right? So per agent, which handles the agent-specific communication, sorry, agent-specific pod default network, right? For service function chaining, we'll be having a global IPAM, which will be used to allocate IP address on the CNF scope. Any questions?
So in your example here, you define the sublets in the spec. Does that mean when user creates a CR, they specify the sublet? That's what I mean?
Yeah, that's right. That is expectation, yes.
Okay.
It is coming as part
In
of
the
the
case
CRD
of
definition.
So in the case of the functional chaining, who will allocate the sublets? You assume?
Yeah, John, here we are defining the networks, actually, virtual networks, how many we need it based on that. And later when we are defining the service function, and we will mention that between the, Arun, you can go to the CR.
Yeah,
service
that's
function.
right.
Yeah.
So if you
Yeah.
see the CR, it would be much clearer. Yeah.
John, here you can see that between the SLB and next-gen firewall, you can see the virtual network one.
Right.
Yeah. So this is what tells us the controller has to now see this, visualize this based on the network chain, and he should be able to allocate one interface on SLB towards the subnet and one interface on next-gen firewall towards the subnet.
Yeah, got it. I'm just trying to understand in the completed solution, do we have an automated way to allocate sublets for every virtual network?
We can do that, Janjan. We'll come back on that one. Yeah, that is good idea. Instead of hard coding and subnets, yeah, we'll come back on that.
Okay,
Yeah,
got it.
it's good idea. Yeah, thank you.
Sure. Yeah, that makes more sense. Yes. Yeah. Yeah. For now, we focused on defining it through the CRD. Yeah. Yeah. It makes sense to have it dynamically assigned.
Got it.
Thank you. Another main thing here is like the interface creations at the pod scope. We expect it to be pushed through the pod annotation, right? So assuming that this is for your primary and the default network based on the Kubernetes CRD, right? So that's not, that remains intact. For the multiple interface and SFC use cases, we plan to use pod annotation to push the interface details to the specific pod.
Anthony and Janjan, last time as you given the feedback to have the Maltese kind of annotations, we are going to follow the same.
Okay. Yeah, probably I've also checked more inputs from more people here. But at least previously we saw people like Marta's. but probably we can ask more people to see what's their opinion.
Yeah, sure.
Sure.
Yeah, you're probably talking about me, Changer. So, so because we had a use case, if you go back to the packet flow, Aaron,
Yeah,
to
sure.
that side. So our use case was that we wanted to basically have a pod that intercepts traffic, like it could be basically connected, like your SLB. Let's say your SLB is also a pod, you said. So whatever traffic is going from one pod, from resident 1, that's a namespace, I guess, to resident 2 pod is going through the SLB. Let be the SLB our pod, right? So we want to have a packet flow where whatever traffic is going from one pod to another pod is intercepted by another pod.
Right.
Maybe I can draw something.
I think we understood that. Yeah. So, yeah, I think at least we have Saidlu, myself, and Rama has understanding on what you are actually proposing. Jijang, you're clear, right? I think you guys are discussing on the Slack.
Yeah, I think it's like in our topology, it's like something like service insertion. So basically, you want to insert some service in for some specific traffic flows.
Yeah.
Finally, you want to get back the traffic afterward the service to the original forwarding path. That's my understanding of the problem.
Yeah, basically, I think Marcus.
I can draw something here. You guys see it, yeah? So let's say we have, this is one pod, and this is another pod. And let's say this pod is usually sending traffic to that pod, so it goes directly, right? So the idea is that the packets are not going directly to the other pod, so that it first goes to a second pod, it's intercepted, basically interceptor pattern, and then goes to the other pod. So this pod can do some traffic shaping. That's basically the idea. But not only for pod-to-pod traffic, also for ingress and egress. So if there's like, let's say here's some ingress going to that pod, so it wouldn't go directly to that pod. It would also first go through this interceptor and then go into that pod.
Right.
That's basically our use case, right?
Yeah, maybe we can deep dive on this. We would really want to discuss in detail also, Marcus, on that to understand if this can be supported based on the generic functionality. I know that you guys are trying to, I mean, like hijack the flow from OVS bridge, right? Maybe if I understand this correctly. Maybe we would like to understand more on your proposal as well to see if there is a way we can map it with what we propose now.
Okay.
That will make sense, Marcus. We can collaborate and we'll see the common requirements or how we can support with the current existing mechanism what we are proposing, or any extension required in the generic way to support it. We will deep dive that.
Yeah, that's great.
Yeah, thank you.
Okay, great.
Yeah, thank you. Yeah, so this is the network chain CRD. The main point to understand here is, like, as we discussed, we talk about the left provider and then right provider network. And then we have a chaining attribute, network chaining attribute, which talks about chain between what CNFs, so chain between the CNFs, right? So in this case, we take SLB and there is a virtual network 1 in between these two. So basically the SLB and the next hop is going to be your next gen firewall. So connecting these two CNFs virtually through your virtual network 1. Right. Likewise, your next gen packet, when the next gen functionality is done, the packet forwarding has to happen by default to through your virtual network 2. Ideally, this is actually virtual network 2. Sorry for the typo. This is virtual network 2. And then it goes to your SD-WAN use case. So once the SD-WAN CNF functionality is achieved, he's going to go through a default network, right? From here, it goes out of your provider. Yeah, exactly. Thanks, Ailo. It's going to the right provider network in this case, right? So basically the packet originates from here, goes through this chain of chain, and then goes out of your right provider network, right? This is what the CRT is about. So now the Antrea controller needs to understand this and define the virtual network, create the virtual network, assign the specific pods into the service function chaining.
Yeah. Anyway, Arun, I think in the previous one we can stress that what are the interfaces are required for the each pod. The previous CR shows it. Right.
Yeah.
Next one, pod annotations. Yeah.
Yeah, so as we see that we send the pod annotation to say there is a virtual network 1, so we say ETH1 and the ETH2 interface for virtual network 2, right? So if you take NF NG as a next gen firewall, right? So next gen firewall needs to be part of your virtual network 1, and he needs to be part of your virtual network 2 as well, right? He is going to ingress the traffic here, egress the traffic here, right? So that definition is pushed to the pod as part of the pod annotation.
And we have one diagram also. I think we can explain through that one.
Oh yeah.
Yeah, this thing is.
Sure. Yeah. Yeah. So to have a little more details here, right? So provider network, it goes to the NGF, and then it goes to your virtual network 1. As we discussed, it goes to SD-WAN and goes to, though we say SD-WAN, basically it's your right. Basically, it's your provider network, and this is your left provider network. Sorry, right provider network. This is left and then right. So basically when the communication goes from your core network to the internet, in this use case, we go and virtually chain this through my service flow, right? So to achieve the corresponding service level agreements for a specific flow.
Could I take a look of your chaining CR again?
Yeah.
Okay. So why we need to define the gateway IP and the subnet for the left network and right network?
You need to give the gateway address for your left provider use case, right? So in this case, I would assume that the guy who is connecting to here, he should have a gateway address which is supported by the SLB here.
It is basically defining the provider network one, Janju. It is similarly kind of virtual network.
I see. So you mean we can also use the CR to define left and right?
Yes,
I just want to understand why we handle left and right separately.
Yes. Yeah, we can define there also as using the network CR. We can define these two things.
Okay, got it.
Okay, so basically we need to this left and right is required as in a way to means get the origination of your traffic and your exit of your traffic, right? This is your ingress of your traffic. This is your egress of your traffic.
And basically we can define using the network CR, left network and right network. We can mention in the chain actually, right? That is also other.
Yeah, that's okay. Yeah, I got your point. Yeah, sure. Yeah, makes sense. Yeah, we can modify that.
Got it.
Yeah, so the key points to mention here is like what we look at from the Antrea point of view, right? So when we talk about chaining in this case, so because we still talk about CNF being part of the same cluster, right? So as far as Antrea is concerned, any communication within the cluster is going to go through the tunnel, right? I hope we are not missing any use case which is not using the tunnel in case if you're talking between pods or pod and CNF. Is only through the tunnel, right? Yeah. So yeah.
Go on. Nothing.
Oh, sure. So the key point here is to say like whenever you define a new interface, we need to configure the OBS bridge as in a way that the service function chaining is handled through your tunnel. It's not going to reach your default gateway. The default gateway is used only for your left and right provider network. right? Otherwise, if you have n number of chains, you're not limited to 2 or 3, right? So we can do n number of chains. So all communication between chains are going to go through the tunnel as far as your CNFs are bound to be in 2 different nodes, right? So if your CNF, network CNF is actually in node 1 and SD-WAN is in node 2, it's going to go use your tunnel communication. So if both the CNFs are being apart in the same node, it's going to use your typical in-node communication, right? It's going to be locally terminated. It's not going to go through your, it's not going to exit your OBS bridge, right? It's a typical use case. See, if a typical Antrea use case, like any part-to-part communication within a node is local, any part-to-part communication between nodes is going through the tunnel. So we still maintain the same flow for communication between CNFs among pods. Is clear, right?
Yeah. So as far as packet routing, so when packets need to go from NGFW to SD1, that means NGFW is aware of the IP address of
SD-WAN.
SD1.
Exactly. Yeah, that's what the controller's job now, to visualize this and assign the corresponding subnet. As you can see that 33.2 and 33.3, right? So 2 interfaces we have, which is assigned with the corresponding same, for example, let's say like virtual network 1, right? Both of them owning an interface on the same virtual network 1. So this is visualized by controller, and he assigns the interface IP, and then he has to do a routing configuration as well, route configuration as well, to put the packet. Let's say you have an ingress here. The egress of next-gen firewall should default to your this interface, right? As of now, the Antrea has the default route towards your default network, right? For example. So we are going to modify the default route to always go through your right side network.
And also we are preparing the demo. We are implementing that. Maybe in next 2 weeks or sometime we can provide the demo.
Yeah, I was more asking about so the next gen firewall, when it's sending packets, how does it know that SD1 was assigned the IP address 33.3 here?
Yeah, that
based on service chain. Yeah, go
yes. Yeah, right, Silo. So it's based on service chain, right? So this is what we see. This has to be visualized by the controller now, right? So there's, for example, if you take a next-gen firewall, he is part of your virtual network 1, and he's also part of your virtual network 2. Sorry for the typo. This is 2, right? So he's part of two different subnets, right? This is when the controller reads about your network chain, he sees this, right? He sees this, and he's going to configure your agent. The agent will get the configuration request as in form of the pod annotation to define the specific thing. That's what we are also going to use the global IPAM to get an IP address from the specific subnet.
Yeah, but I'm not really. I'm talking specifically about the next gen firewall software, which is like processing packets, and when it's done with a packet, how does it send it to the next hop?
Yes.
Yeah.
Who sets a destination IP address? Once a destination IP address is known, I understand how the packets go to the next CNF. But
right. So basically, when the next gen firewall is done with this job, right, he's going to push the packet out. So when it comes to you, the typical route lookup is happening. So when you do a typical route lookup, so your default route is going to point towards this network. This is configured as part of your chaining.
Why is it default?
So Antonio, I think it doesn't know the IP of the SD1, that's my understanding. It just know the last hop is
subnet. Yeah, it knows the subnet.
Exactly. Yeah. So it's a typical example of your Antrea, right? So even in Antrea, so any traffic which is destined any IP address, right? So we have a default route 000, right? It's by default point towards the Antrea ETH0. The same logic is followed here. We just modify your ETH0 to the ETH1 in this case, for example.
Okay, but my packet going out, it has an IP header. What does the destination IP field says in that IP header?
So your destination IP address will be your actual destination IP address in the internet, for example.
Okay.
Right?
Yeah.
Yeah. So, but then when you send the packet, you are going to do natting in this case. So he's going to go with this. Yeah. Your destination will be your internet traffic, your end destination.
Yeah, that's never rewritten. Yeah, that makes sense. We talked about this last time. Yeah.
Right.
Yeah, yes.
We have a question on the chat. I can read it if you want to.
Please.
You can read it.
I don't see where it is exactly.
I can read it for you. From Pooja, will we be inserting something in the Geneve overlay header or use a TLV to track the chaining?
Not really. Yeah, go ahead, Saidlu.
Yeah, Pooja, we are not inserting anything for the chaining because we are completely depending on the SFC CR. So based on the CR, we are going to route the traffic. We are not using Geneve header because or TLV, because if Geneve is not supported, only VXLAN is supporting, then it is not easy to support.
Great. Yeah.
You will
So
help in telemetry to see how the packet is going, right?
Yeah,
It
telemetry
would be a
part. We are
value
going.
added feature if if it's going through 4 or 5 different chains, if it gets dropped somewhere or something happens to the packet, how do we track it?
Yes, Pooja. For telemetry and debugging purpose, we are planning that. But for the functionality point of view, we are not using that. For the telemetry and for the other purposes, we are going to use that.
So you're going to use like a Geneve header. Okay.
Yes,
got it.
yes.
thank you. Any other questions we have? That's great. Yeah, so we're going to take a phased approach in this implementation. So before one of the base requirement for us to support the SFC is the multiple interface support, right? So that we are taking it as a phase 1 implementation on Antrea. Once that is achieved, so we will enable support for SFC with single function chain. So while we discussed a few weeks back, Antonio and then Zhejiang had a question like, hey, how do you guys going to support multiple service function chain, right? For example, if specific flow wants to go a specific chain, right? Currently, it is not as per the phase 2. It will support only a single SFC. So which means any packet which is going out of a specific part from your left wider network is going to go through a defined single defined SFC. Okay, so as a phase 3, we plan to support multiple service function chaining on Antrea as well using the classifier that we still are defining the requirement for. So it's still in the early phase of defining a requirement to support multiple SFC. Functionality support, multiple interface and SFC is achieved as far as what we discussed in slide 6 to 8. If this is achieved, which we can safely claim that multiple interface and SFC support is enabled in Antrea. For multiple service function chaining, that's what I said, we need to have a classifier based definition, which we are in a very early stage to define that. We are working on a requirement to define multiple service function chaining in Antrea. Yep, that's all we have. Any specific questions?
So I have another one. So in your chain, I think you only in your chain for a given service is only a single instance, right? But in the practice, does any solution support like a multiple instance of a single service? Like you can.
Yeah, yes, Janjan. In the along with the classifier, we are going to support multiple instances of the single chain. Example where next gen firewall, you might based on the load, you may span some more next gen firewalls. You can say 8 or 10 or 15 pods you spawned on next gen firewall. Load balancing between them based on the MAC address. We internally we defined the solution. Just we are reviewing that one, so we can present in the next when we are giving the demo. Along with that, we can present load balancing also.
Okay, let me try to understand. So I think for the first hop, I think I can understand your classifier can decide which will be the instance to handle it. But for the intermediate hop, how could the last hop decide which instance of the last hop for the traffic?
Based on the service function definition, service function chain definition, left network and right network, right?
Sure. For example, in this example, if you have multiple instances of ng file, how SLB knows which will be the next one?
Yeah. So every SLB we will have the MAC address based instances. We are going. Example, you are having the next gen firewall, maybe 10 instances are running. Then along with the SLB, we are going to bring up a kind of small load balancer along that one. So it will keep track of all the instances of the next gen firewall. Then it will load balance. Yeah.
Got it. It's based on the MAC address.
Yes. Yes.
Okay, got it.
Sorry, in this case, is the load balancing done by SLB or is it done by OVS?
We are still debating that. Okay. I can come back on that one. So, but at least we need to track all the MAC addresses of instances which we are spanning. So that we are going to.
Got it.
Yeah, thank you. So we plan for a demo on this. Like we have implemented hacks. It's kind of a POC solution on the Antrea. We targeted to give today, but then there are a little more pending on that. So we would definitely be able to showcase that by next community discussion.
Okay.
So maybe we can take up this topic further with Marcus. Marcus, you would like to?
Could I ask one more question before that? So in your plan, you plan to use the same OS bridge as Antrea OS bridge or BR-int bridge, or you plan to create a new one?
It's the same bridge. There is no additional bridges required in this case.
Maybe we need to add
additional flows. Yeah.
Okay.
Additional flows. Indeed, the current POC also target the existing code as far as you give the subnet information. So it would create another veth pair and define the OVS flows automatically for the new set of addresses.
But in theory, you can also create another bridge, right, for the secondary interface?
Yes, we can. But do we see any benefit of doing that?
I don't know. Originally, I probably just like I don't know how you are going to add flows. Originally, I was thinking if you want to add a totally different set of flows and don't want to interfere with the existing flows, maybe you can create a bridge.
Yes, Janjan, both we are thinking through actually. So at least we are currently implementing with adding the additional flows.
Right.
And we will think through if anything is conflicting with the existing flows or any problem we face. Obviously, we create the second bridge. The work will be the same more or less here.
Right. Another thing that since you are connected to the private network, right? I assume it's a VLAN network. Then you need to add the uplink to the bridge, right?
Yeah.
I'm not sure that will impact the Antrea BR-int bridge or not if you move any physical link to the bridge. In some cases, probably you even need to move the IP to the bridge. So I didn't think through it. I'm not sure what will happen if it's the same bridge.
Maybe I didn't get that correct.
Yeah, sorry. Why do you think they have to move the interface to the bridge?
I mean, if we want to connect private network, it must be some VLAN network, right?
Oh, there.
So you must have a physical interface to be the uplink of the bridge, so you can send the packet to the VLAN network. Is that true or not? I guess so. Either you directly connect the interface to the bridge, or you create another bridge and connect to bridge. Sure. How about let's talk about offline? Since I didn't really spend much time, so maybe don't have much to discuss here.
Yeah. Yeah, we can, as Sailu said, we will deep dive a little more into see like how what benefits we may have with two different bridges.
Yeah.
So currently, like the flow is defined as in a way like you are giving another subnet, and you go and modify your OVS flow. That because it's going to go through the tunnel, right? So you will just mask your source address, and exactly the same kind of mechanism, like how it goes between node to node right now. Yeah.
Okay. If we can see your example implementation like the flows and the bridge setup, then probably it's clear to us to understand.
Yeah, exactly.
Sure.
Ranjan.
Yeah.
Based on the whatever POC we are implementing it demo, so those flows we can review it in detail.
Yep.
Exactly. Yeah, that's what we target to give today as well, but somehow it got delayed a little more than what we thought. Yep. Thank you. So Marcus, so you want to go a little more on your use case, and we can try see if maybe you can go through the use case and see maybe if you can visualize it here. Is there a way that we can use this service function chaining for CNF to achieve your use case as well?
Yeah, that would be great. Yeah, what we're currently doing is that we deploy basically a daemon set, and the daemon set is also with an init container changing the open flow rules to redirect the traffic to those pods, right? I think I sent this open flow rules to the channel. So that currently works quite well, except that we have problems with ingress traffic, which I think Yuhan, he's also in the chat. He's mentioned the exact problem in the chat. So maybe we can have a look at that later too. But I wonder how our use case will now map to your proposal. Because if I see that it's I don't understand yet how your proposal would work with pod-to-pod traffic, like in the same cluster.
Yeah, so maybe what we can is like, okay, so pod to pod, possibly that the actual thing, right? So the pod has to default its traffic to the CNF, right? And
Exactly,
kind of, yeah, basically the CNF will be your gateway, right? It just take a home use case, right? So we all have home devices connected, and then there is a gateway router at our home. So assume that gateway router as your CNF, right? So all the communication has to go through your gateway, in this case, your CNF, right? Like how I talk between my device 1 to device 2 at home, right? Through my home gateway router, right? So maybe we can have communication go through the CNF. So the CNF can decide whether to allow the traffic, means basically you can do a traffic shaping there. That is one possible thing, but maybe Sidely, you want to add something with this?
No, you go ahead, Aaron. Yeah, just I try to understand Marcus' use case. Marcus, if I understand right, your use case, you want to redirect the traffic between the pods, right?
Not necessarily redirect. It's more like a filter. So it should end up at the same pod, right? So this, like if we have now, let's just draw this CNF here, right? So it's definitely connected here to the network, and it will have traffic sending from that pod, or let's say like traffic that's going from that pod to this pod here should be intercepted by another pod. So basically like a filter. So for that, network function is then not rewriting the packet. So we're not redirecting the traffic, changing the destination IP to another pod, right? So it's just like going as a filter to this network function.
Marcus, in your case,
traffic flow we set up.
do you assume there's no change in the application? So for example, for your source port and destination port, they should not be aware of the service you inserted, right?
Pardon? I didn't get that.
I mean, from the port perspective, from your port's perspective, they should not be aware of the service you applied, right? They are just talking to each other from their point of view. Yeah, true.
So they're talking to each other, yeah. So it's not changing any packets. This let's just call that filter, yeah.
Probably you don't want to use secondary interface, whatever, right? The port just have one IP and one interface.
This port could also have another one, so we could like have a second interface also connected to that interface to that network here, and so the traffic shaping is handled by one interface, and this interface is probably used for, I don't know, for HTTP traffic, sending out some data or something, also done in that pod.
But what IP will be used for your traffic? These two interfaces all have IP address, both have IP address, or only one interface have IP address in your mind?
Both have an IP address, yeah.
Okay, you are saying for traffic require shipping, we can use the secondary interface and the secondary interface IP address to communicate.
Yeah, exactly. Yeah, so it's not a problem. We were trying to use Maltus to add a second interface, and that second interface would just do the traffic shaping.
I see.
So what is the actual use case we try to address with actually it's basically a traffic shaping, right? So
yeah,
we would like to know.
So what we can do is, for example, is two use cases. Like, let's say we want security. We don't want dynamically decide that this pod is not talking to that pod, right? So the filter just doesn't allow it. Or it does rate limiting, reducing the amount of traffic within those pods.
Okay, so this can be in one way, this may be a bottleneck, right? Or unless you have some ways to overcome that. Just trying to understand more. Means basically the expectation here is every traffic must hit through an CNF, right?
Exactly, yeah.
So it's between pod, it's within the node or across nodes. It has to go through your CNF.
Exactly, yeah.
Yeah, Marcus, basically
yeah, sorry?
No, basically you are trying to use the CNF to filter the traffic and rate limit. So you are going to implement the functionality within that particular CNF, or you are going to use flows to control like ACL flows in the OS?
No, the functionality is in that pod. So the flow, so it should be done in user space from the pod, like the decisions based on application labels and so on. So it's a bit more complicated, right? It's not just possible to do that with some rules. That's why is there a specific process running with that. Yeah.
Yeah, Marcus, is it will be the single pod or single CNF, or is going to be multiple CNF in future you are going to use to shape the traffic?
From our use case, we just need one.
Okay.
We don't need multiple.
Okay.
Yeah. So Sidelu, the key difference I see here is like the actual service function chaining will be handled based on the route modifications as well, right?
Yes, yes.
So in this case, it should be seamless for this use case, if I understand this correctly, right? So pod A to pod B should be seamless. I mean, like we cannot modify the routing table of pod to divert the traffic through CNF. It may be an easy case, yeah, but yeah. Right.
So basically, Arun, they are going to have the pod. which will share the traffic. When the traffic is coming to that pod, the pod will have the rules or some mechanism.
Shaping. Yeah.
Shaping part.
Right.
So it is, I think use case is more, I think it's a different from currently what we are proposing in the SFC side.
Right.
We can think through, can we use SFC? Like you can assume that SLB kind of one part, but it is not chaining. We have to think through.
Yeah.
Right. I think this one is different from CNF actually. In WebML topology, we call it service insertion. Basically, want to insert some service, and in our case, we saw some service can be some physical network service. For example, a Palato firewall. That you want to insert service for specific traffic. But once the service being enforced, we want to continue the forwarding path. Yeah, that's my understanding of the problem.
So Marcus, is this a supported use case in some other form? I mean, like other CNI support this, or I'm like, maybe we are just trying to understand if this is an implemented or kind of a working solution from your point of view, or I mean, or you're exploring this as a new use case for Antrea?
We're using that already similar with on top on Istio.
Oh, wow.
So Istio is like, so it's a very similar like idea, just like instead of doing it, Istio basically has, just for those who don't know, have like, there's a layer 7 proxy for each pod. And then the communication between each pod is then always interjected by the sidecar, who could also do rate limiting, or could also decide to drop the traffic, right? Just like I think it's more elegant to solve that problem on layer 3. So that's why we bring in basically this, this kind of functionality in on layer 3. That's basically what we want to do.
Mm-hmm. Yeah, so our current SFC proposal may not address this, right? So it should be seamless. If we are okay to modify the route update on pod, then yes. Ideally, it should be seamless, right? In this
right. Actually, I was thinking about some. I'm just thinking a lot. I'm thinking. If we take your service chaining approach, what can happen? We can still define a chain, and then for the classifier, we just need to define some way to say for given traffic, for example, from port 1 to port 2, we are saying this traffic should enter the chain, and then let's assume we have some flow in the OS bridge to capture the packets, and then redirect your service chain. And of course, in the specific case, Marcus one, in his chain, he has only one service, and that is some shipping service. But to make it more generic, we can still use your chain definition. We can allow multiple service in the chain. For example, we can do shipper and then ng firewall. But at the end of the chain, there's no write network. We just say the packet should follow the normal forwarding path to the destination port based on IP address, for example.
Yeah, with classifier we can use that one. Yeah, second chain.
Yeah, Paul, that's just my, some rough ideas.
That's interesting.
So, Chen, just to understand you, so basically we define a chain like that one here. That's just either a chain. And then we have some matching that either ingress or egress is matching that, or pods are matching this chain, right?
Right, basically the classifier in Aaron's proposal.
Mm-hmm.
That classifier implementation were just probably based on some matching criteria to see what path should be forwarded to the chain.
Yeah.
But this has to
it's a
happen for
chain
all
with
the pods.
It's a chain with a single service, right?
Right. In this specific case, it's a single service chain.
Yeah, so basically
Yeah,
any
that
traffic.
sounds like it could cover our use case, yeah.
Yeah,
Oh, sorry.
Yeah, and I think with the classifier, we can cover that particular use case where we have the multiple service chains.
Oh, okay. So maybe I can take this offline with you to understand more, Sidelu, but maybe I was just trying to understand how the classifier can be used between pods in a node and there is a tunnel communication, right?
We can add in the classifier certain rules, ACL rules. Anyway, obviously we are thinking
Okay.
in the similar direction, right?
Yeah, okay, yeah.
So
Yeah.
if that is matching the particular criteria, we can divert that into separate chain where it is a service ingestion kind of use case.
So basically, in that case, the left network and the right network, right? Those are the actual default pod network, default Kubernetes pod network.
Yes, yes.
Right, you can see it.
Okay, guys. So sorry to interrupt. We have like 2 minutes left. So I think we can keep discussing this offline. And since we have a few minutes left, is there anything that anyone wants to bring up?
Antonin, our side, we are going to provide the demo. Offline, we'll discuss with you on the Slack.
Okay, perfect. And please send me the slides, Arun, so I can upload them to
Oh, sure.
to the
Yeah.
Antrea wiki. Yeah.
Sorry, we missed to send that last time. So we will.
No worries, no worries. I think those have more info. So I mean, you feel free to send both slide decks if you want. But.
Sure, thank you.
And yeah, so I think next community meeting on December 21st, we can do 30 minutes on the Antrea retrospective, release retrospective with Stephen Wong, and we can reserve 30 minutes for the demo.
Okay, sounds good.
Great. Thank
All
you.
right. Thanks everyone for joining. Thanks Arun and Sidelu for the presentation, and I'll see everyone in 2 weeks.
Bye.
Thank you.
Thank you all.
Yeah. Thank
Thank you all.
you. Thank
Have a
you
good night.
guys.
Thank you.